to gain some insight in how this ELS functions, we can have a look at the menus here. First, you have the turning menu, where you can set the feed rate and the set and X axis parameters. And then you go to the boring and facing and parting menus through to the undercut, which is for the threads, external and internal threads. And then in addition, you have a different menu for external threads explained in the manual. And then you have tapers, external and internal tapers. You can do radius cutting, I mean forming with forming tools. You can have grooves. And then you also have a grinding, boring and drilling setting. And then in addition, you can also use this angle setting to, well, for division, for instance, to set the angles. You just read out the angles from the encoder. In addition, you also have the keys, the keypad here, of course, to move in without the menus. You can also then see if I set turning parameters here and start the spindle, that the spindle here then rotates with almost 1000 RPM, and then you can use this as a readout, and then also you have the X and Z axis readouts there. And then when you set the spindle on, you can then move on to start, and then you will have the turning parameters read out to you. Like in this case, I have a feed rate of 0.2 of a millimeter per revolution, and then I have an in feed of 1 millimeter, and it's suggested that I go 5 times 1900ths of a millimeter, and then plus a finishing cut to obtain the different or the set desired cut I want here. So I go 20 millimeters to the left and 1 millimeter in. And then while the cut is in progress, you can follow this here on the display, seeing this, using it as a DRO. And then also, of course, then if you want to intervene, you can do that with the stop button here. I'll show you a little bit of the setup parameters. That might be interesting. I won't go through all of them, but at least here we can set all the parameters needed for the operation of the ELS and the motors, and to adjust it to this size of lathe. So I will have English language, of course. I want to have the X and Z axis not inverted. You can do this if you want to, depending on the situation. And then I can set the rest positions for X and Z, where the tool will park, so to speak. And then important, set the rough and finishing depth of cuts. Same for the set. And then you can also reverse the motors, not so important, but at least you can do that, both. And then important, you can set the fast feed, to minimize the amount of time. Of course, you want to do this together with the acceleration, so to the two repositions. The slow feed, of course, is important also. To set the different, let's say, the turning speeds. This is also then for using the buttons, this jog and fast, slow, or fast jog buttons. And the acceleration, of course, not to overdo it here, but at least have some. I think this is a default situation. And then, of course, important how the settings here is determined by the settings in the different drivers and encoders. And also nice to have, so
for instance, in my case here with the gears, I did expect some more backlash. I didn't really measure that, but anyway, you can set a different backlash both for X and Z. Spindle speed, or the feed, of course, important. And also, if you don't want to have an X, in this case, traverse motor here, you can then undo this. The same as we had for X will be for the Z. So you go through all these for both X and Z. And the spindle feed rate here in this case is set by 3.175, which is the imperial, or the metric conversion of 8 TPI. And the other one for X, that was for the 2mm lead screw we had. But this is how you can then use, don't have to do anything with the 8 TPI lead screw, you just set it up here. And the encoder, of course. You see, there's a long list of different parameters.